The A330 pneumatic system supplies high-pressure air for air conditioning, wing anti-icing, water pressurization, hydraulic reservoir pressurization, engine starting, pack bay ventilation, turbofan actuation. High-pressure air can be supplied from three kinds of sources: the engine bleed system, the APU, and two external high-pressure ground power units. Note: wing anti-icing is not permitted when the pneumatic system is supplied by the APU bleed. The pneumatic system is controlled and monitored by two bleed monitoring computers, BMCs. There is one BMC for each engine bleed system. Both BMCs are interconnected, and if one fails, the other takes over most of its functions. An ambient overheat in the vicinity of the hot air ducts in the fuselage, wings, and pylons will be detected by air leakage detection loops. If a leak is detected, a signal is sent to the BMCs, which automatically isolate the affected area. In flight, the primary source for high-pressure air is the engines.
Air is bled from two compressor stages of the engine: the intermediate pressure, IP port, and the high pressure, HP port.
There's an HP valve, which can cut off bleed air from the HP port. It is automatically controlled by the system and will limit the downstream pressure. Note: there is a non-return valve at the IP to protect the compressor against a reverse flow from the HP. The high-pressure section, HP, is only used when there is insufficient pressure from the intermediate pressure output, IP, due to low engine compressor speed. Once the engine compressor speed is high enough, the IP is sufficient and the HP valve closes. The air extracted from IP or HP stage of the compressor then goes to a bleed valve, which acts as a shutoff and pressure regulating valve. Since the temperature of the bleed air is high, it passes through a precooler before being distributed to the users. The precooler heat exchanger uses cooling air, bled from the engine fan, to regulate the temperature according to the demand. Note: an overpressure valve, OPV, will automatically close in case of pressure regulation problem.
Engine 2 has an identical bleed system. Both systems are connected by a crossbleed duct. A crossbleed valve permits their interconnection or isolation. The APU can also be used for bleed air supply. This is usually done on ground for air conditioning and for engine start. However, APU bleed air is also available in flight.
APU bleed air is controlled by the APU bleed valve, which operates as a shut-off valve and will be kept open by the electronic control box, ECB, as long as the altitude is lower than 25,000 feet when climbing or 23,000 feet when descending. Note: a non-return valve protects the APU compressor against a reverse flow from another supply source.
Should the APU not be available, two high-pressure ground power units can be connected. This completes the pneumatic system. We will now show you how system information is displayed to the pilots.
Information on the pneumatic system is displayed on the lower part of the ECAM bleed page. Note: we have shaded the upper part of the ECAM bleed page because it is related to the air conditioning chapter. This will be covered in a later module.
Let's identify the system components on the ECAM page now. The IP and HP ports, the HP valves,
the engine bleed valves, the precoolers, the APU bleed valve, only when APU is running, the cross bleed valve, and the high pressure ground indication, always displayed on ground even if the ground unit is not connected. The following information is also displayed: precooler inlet, air pressure, precooler outlet, air temperature, and engine identification numbers. Controls for the pneumatic system are part of the air panel, located on the overhead panel. Again, we have shaded those controls which belong to the air conditioning chapter. Each engine bleed valve is controlled by a push-button switch on the air panel.
the APU bleed valve is controlled by its associated push-button switch. The crossbleed selector enables the pilot to open and close the crossbleed valve manually, or to let the system operate the crossbleed valve automatically.
Usually, the APU bleed air is used to start the engines. The APU is connected to the bleed system. You are ready for engine start. Notice that the engine identification numbers have turned white, indicating that the engines are running. The engine bleed valves remain closed because the APU bleed valve is open and the APU has priority over the engine bleed. We can now switch the APU bleed off. Observe the ECAM. The APU bleed valve is closed. The cross bleed valve is automatically closed. It is displayed amber during transit, and the engine bleed valves and HP valves are displayed in line green because they have been automatically opened. We will now talk about the changes that occur in the pneumatic system during takeoff. Note: normally, the ECAM engine page is displayed for takeoff. For training purposes, we will display the ECAM bleed page.
As engine thrust is increased, the pressure delivered from the intermediate pressure stages is sufficient, and the high pressure valves are automatically closed accordingly.
If the APU is inoperative for bleed air supply, the two HP connections of the ground air unit can be connected to provide pneumatic pressure for engine start. The ground unit delivered air, pressure and temperature are indicated on the ECAM.
Notice that in this case, the crossbleed valve remains closed with the crossbleed selector in auto position. In order to start engine 2 first, you have to set the crossbleed selector manually to open. This is done according to the procedure in your FCOM.